In this video, we will go through MediaPipe library for the Python. Let's see how we can use it in augmented reality. So first we have to set up Anaconda environment in your Windows system and navigate to the directory where we have our Jupyter notebook. So start the Jupyter. Here you can see these notebooks. MediaPipe library is developed by Google. This library have a number of other features too. One of the feature is hands, which used to track hand motions. So you can find out all the document related this feature and also its API. So some examples also given here. You can also read the document and implement your own solution. So this example I have analyze and use some function from it. So other features are like this face detection, then mesh. Here is also some augmented reality example given. The other features also are good from this MediaPipe library. You can try all of this. For now we will go with the hands. This MediaPipe support this much platforms, and also some features are not supported on all platforms. So open our notebook. This is a simple example of MediaPipe. First we have to install requirements, libraries and all the Python requirement. So these commands do this for us. Import the required libraries. Some of the important libraries are MediaPipe and all the rest of the common Python library. Here initialize the MediaPipe, and this hand features are get detected. These are the landmarks. There are total 20 landmarks you get. All have index. Result will consist of these landmarks. So these are the basic functions for plotting our landmark information. The main functions start from here. We open the video camera, grab the frames, and also we initialize the MediaPipe library for the hands with some predefined parameter. You can tweak according to your video. So this loop will continuously grab the video frames and pass it to MediaPipe hands library, and this will generate result, and that result will be get plotted on the image, and that image same for the all landmarks and its connections. So these functions are defined in MediaPipe library. You can customize your viewing landmark viewers. So this resultant image will give you all the landmarks and connections. These are the functions where we create a skeleton of hand, raw only the hand without the image. So we will then destroy the video object, but we will continue to grab the frame until we press Q button. So let's run the program. Two windows will be open. One is for video feed, another is for the raw hand positions. This library support a multi-hand detection. So you can see I get the all landmarks, 20 landmarks are there, and also the location in the 3D plane, like it is a XYZ coordinates for all the landmarks. That means your fingertips are located from the origin, which you can see the end point of the hand. So you will get the z axis also for each coordinate, which is also it gives the information how far your hand is from the camera. So you can see the hand nearest camera have the large landmark showing. The next thing is we can do a augmented reality with this library. So we can move the obj file, which is a 3D model file, from information taken from the hand gesture. So this notebook will do for you. These are the 3D models. You can change it any at inside the script. So open this notebook here. Now this notebook is similar as we see the last one. These are some library imports. Here we only need some extra libraries, OpenGL and Python py games. So the rest of the things are the same, but here one extra thing also there. It is obj parser, that is object file parser, which renders that parsed obj file and put this on the image buffer. So some of the supporting functions are defined here. These are the AR related functions which you can later use for image markers detection. These are some feature plotting functions for MediaPipe. Sorry. So these are the video open, and now these are the important matrix: projection matrix, camera matrix, and the homography matrix that projects the 3D image on 2D plane. These are the similar loop we have seen in the last notebook. Here only what we are doing is getting the hand landmass, make them 4 landmark we are getting, that we are considering it as a plane or a rectangle, which is transformed accordingly that points, and we plot that points on the image. We get the plane is nothing but the created using 4 points. That plane gives us the homography matrix, and that matrix is projected inside in the 2D plane. So we load that. We also transform the object file accordingly our projection matrix, and that will make the 3D movement of the object. These are some AR related example. You can also try this. So let's run the notebook. Here we have got the video feed. If you put your hand in video, you can see that the 3D model of mouse is load on the plane, which is created by the 4 points from hand landmark. So if I change my hand position, that plane get transformed, and accordingly that transformation the 3D object get transformed. So also you can create a plane using 3 points only. I have taken the 4, so that's why it's not at the center. Object is not at the center of the plane. So you can also try with the 3 points. So here I have added 2 objects. One is for left hand, one is for right hand. So other is fox and one is a mouse. So as you can see, the models are changing its rotation, transformation and scale according to your hand position. So basically when that rectangle get transformed, the model's orientation and all the coordinates get transformed accordingly. So you can change your other parameters and try your own example. This one is for the augmented reality one. You can find this repo at GitHub. Feel free to contribute or feel free to add any issues or suggestion.